Now we will go into the next method, which is Park method. So what is Park method? Park method is the relative comparison technique where it compares each concept relative to a reference or datum concept or product, and for each criteria determines whether the concept in question is better than, poorer than, or about the same as the reference concept. However, the design concept which to be submitted for the Parks method should all have passed the absolute filter, which is discussed in the previous video. So basically, Park method is the tool that we will use for the evaluation and selecting the concept. There are 8 steps in Parks method. First, choose the criteria for which the concept will be evaluated, normally from the House of Quality document. Second, formulate the decision metric. Third, clarify the design concept. 4. Choose the datum concept or the reference concept or reference product. 5. Complete the metric entries. 6. Evaluate the rating. 7. Establish a new datum and rerun the metric. 8. Examine the selected concept for improvement opportunities. Later in this video, I will show some example related to Park method. This is the example of Park method, where the example of MER will decision metric. So as you can see here on this section, this is the issue or the title of this table, where the issue or the title is to choose a MER wheel configuration. Then we have the alternatives, where we have the baseline and we have the design concept that we want to make comparison between the concept to the baseline. Third is the criteria that we want to make comparison from concept to the baseline. So here we have 4 example of criteria. So the first one is mass efficiency. The second one is manufacturability. Third, available internal wheel volume, and then the stiffness. So here we have the weightage or the importance of this criteria. So let's say we look here. For the mass efficiency, the importance or the weightage is 35. For manufacturability, the importance or the weightage is 10. And then for the available internal wheel volume is 20. And then the stiffness, the importance or the weightage is 35. If you can see here on the importance or the weightage area, the numbers or the method that the table use is the total amount of 100 point. So the importance of this criteria is limit on the total of 100. So as you can see here, the most important criteria will be the mass efficiency and the stiffness. The middle weight or of the criteria is 20, which is the available internal wheel volume, and the least important with a value or a point of 10 is the manufacturability. If you add these 4 criteria, the weightage 35 plus with 10 plus with 20 and plus with 35, so the total numbers or the total figures is 100. Means that the importance or the weightage is based from the point of 100 or marks of 100. So the marks of 100 will be distributed according to the criteria, the importance of the criteria. If the criteria is very important, so the value will be higher. If the criteria is not very important, so the value will less, yeah, as you can see here. Next, we have the area where the evaluation will be happen. So let's say we consider the cantilever beam. The concept of cantilever beam will be compared to the baseline. So let's say we want to consider the first criteria, which is mass efficiency. So when we consider the cantilever beam to the baseline with respect to criteria mass efficiency is 0. So 0 means that the characteristic between cantilever beam compared to the baseline in terms of mass efficiency is about the same. And if we consider again the concept cantilever beam to baseline with respect to criteria manufacturability, the evaluation still 0 means that there is no any significant difference between cantilever beam to the baseline in terms of manufacturability. Now, let us consider again the cantilever beam with respect to baseline in terms of parameter of available internal wheel volume. So, when we make the comparison, cantilever beam score 1 compared to baseline. So, the 1 here, the value of 1 here represent the cantilever beam with respect to available internal wheel volume is much better than the baseline. So we put positive value 1 here. And then for the last criteria, which is stiffness, the cantilever beam score 1 also when compared to the baseline. So it means that the cantilever beam with respect to stiffness is much better than the baseline model. So the score is 1. Now let us consider concept hub switchback for criteria manufacturability. Here we see the comparison, the result is -1. So the -1 means that the hub switchback in terms of its manufacturability is poorer than the baseline. So we give -1. So next we will calculate the value for each concept. So how do we calculate the value? Is by using let's say for example we consider cantilever beam. So cantilever beam we have 0 times with 35, it will become 0. And then we have 0 again for manufacturability times with 10, it also will become 0. But for criteria available internal wheel volume we have 1, and for criteria stiffness we have 1. So 1 times with 20 for criteria internal wheel volume, so 1 times with 20 we have 20, plus with 1 times with 35 for stiffness, so we have 35. So 20 plus 35 we will get 55. And also the calculation is same for the others concept. Now let's say you have finished with your evaluation here, and then you have finished with calculating the value. So normally we will take or we will choose the final concept or the selected concept which have the highest weight total marks. So for this example, the highest weight total is the spiral flexure. So usually we will take concept spiral flexure to the next step in the process design. Here is the example number 2. Here I want to show you the method for evaluating. In previous slide the value is 1, which is better than 0 is about the same, and then -1 means that poorer than. So here for this Park Spark table, the evaluation use the positive and negative and S. So the positive here means that concept 1, when compared to criteria catch area compared to the datum product, which is rollback goal pro. So plus means that concept 1 is better than rollback goal pro. And then the S here means that same. And then negative means that poor than. So for concept 1, in terms of weather resistant, when compared to rollback gold pro datum product, is negative. So negative means that concept 1 is not better than rollback gold pro product in terms of wear resistant. And then the calculation of the value is about the same from the previous slide. Here also example of number 3, which is Spark table. So we have the alternatives, which is design 1, design 2 and design 3. And then for this one, the comparison is made for design 2 compared to design 1 datum, and design 3 will compare to the design 1 datum. For the weightage, as you can see here, they have 2, 1 and 3. So from this weightage, we know that the weightage is use the scala 1 to the 3. Okay, so if the criteria is very important, so the value or the weightage is 3 because highest. And then if the criteria is not important, so it will be put 1 because less important. So the middle is number 2. And basically the evaluation is same on from the previous example. For example number 4, as you can see, there is a datum, and then there is a concept 1, 2 and 3, and then it have the criteria that we want to make the comparison. And then the weightage, also using the weightage scala 1 to the 3. So 1 means that the criteria is less important, and then 3 means that the criteria is very important. And then basically the evaluation is also the same from the previous slide. And then after we have done with the evaluation, we will calculate the value. So let's say here, as you can see here, the highest value is concept number 3, which is 23. So normally we will take concept with the highest value to the next step in design process. So that's the end of module 4. Thank you for your participation and joining this module 4.